now go on YouTube as well. So if you did want to tune in on YouTube, you can find it on our YouTube channel at Civo Cloud. But otherwise, I think we're good to go, Kai.
Cool. Well, thanks very much, Ricky. Yeah, welcome to our 20th Civo Online Meetup. Yeah, I'm so happy that while the in-person events around the world are coming back more and more, we're able to get people joining in from everywhere online, both as attendees like we've got today, from various places around the world, and as speakers like Matt. So today's meetup theme is around monitoring and observability, and we're going to have two talks along with Q&A. So if you have any questions, please use the Q&A functionality. So just to reintroduce myself again, I'm Kai. I'm a developer advocate here at Civo. I'll be doing a quick introduction presentation on monitoring and observability and what those mean. And this is just to make sure that everyone is up to speed on the terminology and concepts for the second presentation and beyond. And we're also incredibly lucky to be joined by Matt Lenhard of ContainIQ. Matt is the co-founder and CTO, and we'll be talking on the topic of extracting value from the Kubernetes events feed, and then looking at some of the best monitoring practices using ContainIQ. Yeah, like I said, if you've got any questions at any point, please, pop them in the Q&A on Zoom if you're listening on Zoom or watching on Zoom. And if you're on YouTube, please hit the stream chat and we will see it. So yeah, let's get started. So I'm going to be doing a quick run through of what we mean by monitoring and observability and some of the sort of big why questions. And as the title says, this is an introduction. It's meant to get you a grounding in the topic. It's not meant to sort of be a deep dive. It'll equip you to do a deep dive yourself and explore the various tools available in the cloud native landscape and sort of explore what works for you in terms of monitoring and observability. So let's have a quick look at what we'll cover. Like I said, we're not going to be doing specific tools in this presentation. This is more of a philosophical overview. And we'll look at the question of why you would want to monitor your apps, how you get from that data that you get from monitoring them to information, and how you get from that information into actionable insights, and then a little bit about the concept of observability and how that sort of fits in with monitoring and how they interrelate. So what do we mean when we say monitor, right? What are we monitoring? And because we at Civo are a sort of cloud native Kubernetes cloud provider, I'll take the example of Kubernetes, where apps are deployed to a cluster in containers, which are grouped into pods and then run on nodes, right? And each of those components, the nodes themselves, the cluster at the top, the nodes, the pods, and the individual containers, each of those produces records. And those records are things like what is happening at any given time, who's accessing what, are they able to hear other things that they're meant to be hearing, any errors that occur if they're not, etc. Right? And this happens on every level of the infrastructure. So a node will have its own system log, and the pods will have pod logs, and each container will record its own logs while the container is around. And you can feed all of that into sort of various types of logging backends and tools and things like that if you want them to be kept around for longer than the cluster keeps it around. But basically, there's a huge amount of stuff. So why are we monitoring, right? So our applications and infrastructure provide us with huge amounts of data straight out the box about their performance. And this is even before you start to configure your own things, right? And so, like I said, we can see error rates and how long requests to an API can take, or trends in demand that help with business planning. So you can control your costs if you see that you don't actually need a certain amount of infrastructure deployed at a given time because your demand just isn't there. So it all comes down to answering the question of, do you know your app is working the way that you want it to? Right? So how do we get to that? how to get to answering that question, right? So we get this firehose of data from our applications, right? They're constantly spitting out data in form of logs about their state and what's happening and what's changing. And in order to gain control over this amount of data, we have to process it to be useful information, right? So to go from data to information, raw facts. So the logs themselves are data, but they're not information. Information is data that is being put into context, and context gives meaning, right? So you can have a stream of data that doesn't mean anything on its own, but when you sort of process it and when you know what it truly means, then you can have information about what's happening. Combining the streams of data can give sort of information and useful insights beyond each individual thing. But the crucial thing is you can't monitor absolutely everything. Not everything has meaning to answer the question of, is my app performing the way that I expect it to, right? And this is monitoring design. So ultimately, you are being given far more data than is probably useful for you, but some of it might be useful at certain times and some of it might not be. So it's up to you as the sort of monitoring designer, so to speak, to coin a phrase, to make use of the data where it's appropriate, right? And that information, when you process it correctly, can give you insights to where your application could be performing better with more efficiency or with fewer errors, right? So now we're at the insights. How do we get to, we're at information. How do we get to insights and action, right? So your insights for action. So how do we know that something is happening and why it's happening? It can only be as good as the data you gather and how you organize it. And the key thing is more is not always better. So you have to be monitoring with intent. So keep in mind that question that I asked at the start is like, is my application performing the way that it's supposed to be, right? Monitoring with intent means thinking about your targets. What do you want to achieve? Like what is it that you know, what do you want a piece of information that you get to tell you about where you want to be? So, for example, uptime, right? How many nines of uptime do you want? You hear this thing of like 9.995 nines of uptime, which is like you're only down for 28 hours a day or something, 28 hours a year. So how many nines of uptime do you want? Which data points will help you achieve that? And how will you know that you don't reach that? So do you have monitoring set up for systems going down? And if they do go down, do you have monitoring that will help you get into the insight of finding the cause of the problem that brought the system down, right? And if your system doesn't get information about what broke and why and when, it's not worth much. So you can know that it's not working because you can't access your website, but you have to know why it's not working, right? So that's monitoring in a nutshell, in a very, very tight nutshell. Let's talk about observability and how that fits in. Well, observability has a lot to do with that insights thing that I mentioned just now. So forgive me, the next slide is going to get a little bit meta, right? Observability, which you often see as O11Y, the same way as Kubernetes is K8s, because observability is a long word. And so you just see it as O with 11 letters and then Y. But basically, observability has its origin in mathematics and control theory and this mathematician called Kalman in 1960. And for him, observability was defined as inferring the internal state of a system from external outputs. Okay, so that sounds a little bit esoteric, but let's take a human example. So if all you knew that somebody had a high heart rate, so the external output is that their pulse is very high, what does that tell you about their internal state, right? They could be scared, so their heart rate is up, or they could have run 10 kilometers just now, or any number of other reasons why their heart rate is spiking, right? You need to know enough about the system's outputs to be able to build a picture of what's happening on the inside. And that's what's observability, right? So in software, it's, then I got this definition from the really good O'Reilly book, Observability Engineering by Charity Majors, Liz Fong-Jones, and George Miranda. It's inferring the current and possible states of a software system, even complex ones, from the monitoring insights. That's observability. So it's by going, because things look like this, that means this has happened, right? So even if things are working well, you kind of know they are working well because our monitoring says so. Or if something goes wrong, you will know what failed and where, and crucially, why. So basically, you can understand the possible states that your system can be in based on what you get given. So this, again, goes back to your monitoring design thing. Are you measuring the right things, and are you monitoring the right things for you to be able to sort of keep tabs on what's happening and why? All right. I did say it was going to get meta. So here's a really good quote that I saw from Helen Beale, who's at the DevOps Institute, that observability is not monitoring. We monitor when we observe our observable systems through tools, right? So observability is a quality of well-designed software systems. There are tools that help you build the monitoring and achieve observability, but you need to keep it in mind what it is that you're looking to achieve with your monitoring. So you go back to that original question of like the why, right? What is it that I'm trying to achieve? Why do I have 2 megabytes of logs every second if you don't know what they're saying and what they actually mean, right? You don't want to drink from the fire hose. You want to be able to know exactly what's happening, why, and when, right? So with that crash course in observability and how it's a quality rather than a thing that you do. So you don't do observability, you have it or you don't have it. Let's do a really quick summary, right? Monitoring and observability are interrelated things, but they are separate. Modern software, especially sort of cloud-based, containerized, microservice software, is ridiculously complex and produces masses of data in the form of logs straight out the box, even before you configure your own custom stuff. It's on us as software writers, designers, to try and turn this flood of data into actionable insights that you can monitor with the intention of achieving what your business targets are. So if you think about DevOps and everything feeding into the next stage, right, and it being a process, you need to have a sort of key result that you're looking for in what you want your product to achieve, and your monitoring and your sort of observability need to feed toward that result. Sometimes less is more, right? So monitoring with intent and not getting lost in the weeds of every possible trace and event is important, especially in the case of you debugging something that's just brought the whole thing down, right? If you have too much stuff, it can be hard to find out what's actually happening when it happens. Obviously, we would like there to not be a situation where something happens, but stuff will happen, right? So the idea is to sort of build software with the observability in mind as you're building it, to try and build systems that you know the internal state of your application's sort of components based on what they give out at any given point. So you know that if microservice A fails and therefore can't communicate with microservice B, and B goes, I haven't heard from A, then you kind of know, okay, that's what this means. And that means that we need to recover microservice A, right? So the sort of having insight into the internal state based on what you get given is the basis of observability and true understanding of your systems. And I realized that I just ran 15 minutes of like systems theory and sort of strange Hungarian mathematicians, but hopefully that has sort of at least given you some idea of what it is that we talk about when we talk about monitoring and observability. And I would absolutely love if there are any questions now, or if you're too afraid to ask right now, then, you know, drop them in the Q&A and I will get to them afterwards. And if, you know, we'll give a couple of minutes, but thank you very much for listening. And I will pass the baton on to Matt.
Hey everyone, thanks for passing it over. I thought definitely really helpful talk. Specifically, I think you nailed some things that people kind of miss when they're first thinking about, designing their systems. Is like, we have all of this data, but like, what are we going to do with it? Because, and I've been guilty of this in the past. Setting alerts on things, and then it ends up not even mattering because it's kind of white noise because they fire all the time. So I think
then you
really
might miss the thing that actually matters because you're like, oh yeah, whatever, like just silence the notification, right?
exactly. Everyone's had that one Slack channel where there's a ton of alerts in it, but it's not really affecting the system. So you just learn to ignore it. And that's not really, what you're trying to achieve. What you're trying to achieve is, these actionable alerts so that when you get them and something's actually wrong, and they give you the kind of resources to quickly debug and get a fix out if you need to.
Yeah. So you want to know kind of what's happened, where it's happened, ideally why it's happened, and then therefore infer out of that kind of what you can do,
Exactly. And the more information you can give yourself, like with the alert itself, it's going to make those like secondary steps even easier. So you know what to do, right? If the alert's kind of like set up correctly.
Yeah, exactly. That is not just like an alarm that goes off. Like, say you have, to take a factory example, and like suddenly the siren goes off, and you're like, is that a fire alarm, or is it, like you kind of know, okay, something's important. But yeah, because we have software and the software can tell us stuff, we can have that feed into the alert and going like, cannot ping this, or latency level exceeded, or processor spike, so we need more capacity, or whatever, right?
Exactly. I think it's nice to start at like a high level, like what you're trying to achieve. And maybe that's, we want the latency or the P95 latency for all of our requests to be lower than this, because when they're higher, users start to complain and they're, frustrated with our website because it's loading so slow, and, help tickets jump. So kind of this, defining what exactly those thresholds you need to meet are, I think is super important. And that's probably dependent on your business. So it's something you should work out with the rest of your team.
Yeah.
And then, putting the kind of the tools in place to be able to accurately track those over time and make sure you meet them.
Yeah, I think that's also really what you said, like discussing with your team, right? So if you are on, software engineering team 1, you might not really even mind that a page loads slowly, but when the customer service team is getting tickets about like, this is so slow, I can't keep using you, we're all on the same team here, right? We're all on trying to get the so an alert that you might not care about sort of personally might actually be really important to somebody else.
Exactly. Yeah. I mean, there's certain things that you might be willing to put up with as like a non-user of the product, maybe only loading one page, but for someone who's got you open in 12 tabs and they're refreshing between all of them, it could drive them crazy. So yeah, making sure that communication between teams is strong is super important as well.
Yeah.
Cool. And with that being said, I will jump into things here. So yeah, I'm gonna take everyone through a little bit more in-depth conversation specifically around Kubernetes and how you can take a sort of a little known resource, or I guess underutilized resource is probably the better way to phrase it, the Kubernetes events, and extract value from them. And there's kind of like a multitude of ways you can do that. I'm going to show you how you can do it straight from like the CLI or using an observability platform like ContainIQ. Awesome. So what is a Kubernetes event? It's basically like, it's a Kubernetes object that's showing like a kind of a change that happened in your system. So, maybe it's a pod being created. Maybe it's a stateful change in the node. The node went from, ready to unready, or, maybe there was a networking change that happened. It really, it sort of acts as like a historical log of everything going on in your cluster. And something, like I said, I think people don't realize like all of kind of the value you can really extract out of having that log. So like, what's the structure of the event? It's basically broken down into the type. So normal or warning, obviously, normal is just something that's everyday occurrence that you shouldn't be too worried about. And warning is something that's probably worth investigating depending on the setup of your cluster.
Just Matthew, just sorry to interrupt. Are you showing your deck right now? Because if you are, I can't see it. What I'm seeing is your terminal.
Oh, interesting. I guess I was going through the deck. Let me repurpose this.
It's always a juggle with desktops, isn't it?
Yeah. Is it still showing wrong screen?
So now we're seeing, yep. Okay, there you go. Yep. There we go. Yep.
All right. Well, I didn't go through much. I really just hit the first 2 slides here. Like what is an event and the structure of the event. So the structure being normal, warning, for the type, and then the reason and message. Reason, it's just kind of like a quick, unique snapshot of it, and message is like a more in-depth explanation. So you could see like the reason here, like the node is sufficient memory, and the message, which is just like a longer explanation of it. So in order to get a list of your events, you can just run kubectl get events. It'll list all of them in your cluster. In order to see a specific event or event specific to a given Kubernetes object, you just run kubectl describe the object and then object name. So in this case, like kubectl describe pod and then the name of the pod. And I can actually just I'll show kind of a walkthrough later of that. I can't actually flip up my terminal now, but yeah, it's pretty straightforward to list like all of the events for that given Kubernetes object. So what are the typical use cases for events? Debugging is one of the most common. So like maybe something's wrong with one of your pods and you want to know why that is. One of the first things I might do is run kubectl describe pod and then the name of that pod, and it's going to show me all of the events that happen. So I'll be able to see maybe the pod recently restarted or it was evicted. It'll basically give me kind of the life cycle of that pod, and I can quickly figure out what's going on. Next is alerting. So you can set up alerts on a lot of these Kubernetes events. And the cool thing about them is they're usually something that you can set them so that you need to look into them. An example is like, say you set up a CPU alert on a given container or pod, and it fires so often that you've learned to ignore it. With Kubernetes, what you can do is you could set up a CPU alert on a node through the node CPU limit reached. And what this means is that that node is basically out of CPU. And so like we have an alert set up on that. And if that fires, I know it's something I need to investigate. So it helps by using kind of the event feed for alerting. You can sort of get rid of those white noise alerts if you use them correctly. A final thing is like using them for analysis. So like I said, it's this historical log of everything that's happening in your cluster. Maybe you want to see how often you're deploying or how often a given autoscaler is autoscaling. You could aggregate those autoscaler events by hour over the past week, and you could see not only how many times is the autoscaler scaling up, but at what times of day. Maybe it's not what you expect. So you can kind of use it to just get better idea of maybe traffic patterns or just the life cycle of events in your cluster. So yeah, it takes me into life cycle events. One of the more confusing things with the events too is that it's very difficult to figure out like all of the events that are available for you. There's not like one giant list out there that has every event. This is kind of twofold. The first is that any CRD, so custom resource, basically can have its own events that it fires. So maybe you're using some third-party CRD that's a little bit lesser known. It's going to fire all of its own events. But the events themselves are also split into each individual object. So like I've found myself looking at like the pod, the code for a pod in the Kubernetes GitHub, and that's going to have all of the pod related events. So they're kind of like disparate in where they're located. So it can be difficult to figure out what events to look for. Luckily, I've seen a lot of them at this point, so I'm here to help you guys figure out the important ones. And another great way is just by like watching your cluster periodically and seeing which events are firing. Downside of this is that by default, EKS, so Amazon's managed Kubernetes offering, only stores events for, I believe it's 5 minutes unless they refire. I think like a vanilla K8s install is like an hour. So if you're not exporting them to some external system, you might be missing a lot of things. And that's something you want to be aware of. So yeah, let's get started with lifecycle events. What are lifecycle events, and how can you use them? So some of the most common ones are the start hooks that fire when a pod is created. So maybe every time a pod is launched, you have some script that runs that provisions things or does something related to your application. Every time that occurs, Kubernetes is going to fire an event. And so something that we watch out for specifically is this failed post stop hook, because every time we delete a pod, we have a script that runs that basically does some meta-analysis on it. And if that fails, it's pretty bad for us. So we need to know whenever that post stop hook fails. So this is an example of something we would like set an alert on. Another great example is the unhealthy event reason. And so this will fire anytime a probe fails. So like we mentioned earlier, like, how do you know when a given, microservice isn't responding? Well, Kubernetes will actually constantly probe each pod. And when that probe fails to respond, or, when it times out, or, maybe you say notify, you set it to a threshold of 300 milliseconds. When it's greater than that, that threshold, Kubernetes will actually fire this unhealthy event. And that could be another thing that you could set an event alert on. So you could know, hey, this pod has stopped responding. The cool part about this too is that, maybe previously you've got a bunch of, you set, kind of uptime alerts to ping your website, periodically. And every time you add some new DNS or a new endpoint, you have to add a new, you have to configure this new ping. The unhealthy hook will always fire. So it's something that's kind of like readily available for you that you don't have to continuously configure yourself. Finally, backoff. So that's like anytime you launch a pod, it crashes, it goes into like a crash loop backoff. This backoff also applies to Kubernetes jobs. So if you have a job that's running and it fails, it'll fire the backoff reason once it exceeds the number of retries. So if maybe you want to get notified every time a deployment essentially fails, you could hook into that crash loop backoff or backoff event. Next, there's a bunch of node specific events. So these could be used to basically monitor all of the nodes in your cluster. So while there's things that are good, like node has sufficient memory, there's also the opposite, which is when your node runs out of memory. So you could do the same thing for, node doesn't have sufficient memory, or node CPU limit reached is a great example of an event that will fire that will be less noisy than setting your own CPU-based limit. So node memory limit reached and node CPU limit reached are two ways that you can monitor basically the health of your nodes while kind of limiting that white noise of like, send me an alert when CPU is greater than X. This obviously depends on your setup of your cluster, because if you have a cluster autoscaler setup, maybe it's okay if your node runs out of CPU and memory because you're going to add a new one. But for people who don't, this can be like a helpful way to kind of like match those use cases. The other cool thing is, like, say you set a CPU limit on like or alert on a given node, and then later on your team resizes the number of cores on that node, and now there's a lot more CPU, and your old alerts are still firing because you have to now go and update all of them because you've changed the size of the node or the VM or whatever the underlying resource is. Like this, the node CPU limit reached event is going to be reflective of the actual underlying hardware, even if it changes. And in this kind of like new norm of ephemeral resources that Kubernetes kind of offers, it's a great way to just reduce the overall burden of having to kind of like update things as you go. Evicted events. So this is, in most cases, it's a precursor to things going wrong. So what an eviction is if your cluster is running out of resources or a given pod is reaching its limits, Kubernetes will start killing pods. So basically things are, in most cases, starting to go wrong. You're hitting some resource limits. We see this when there's like a lot of like, when load's really high. And so this is another great thing that you can either set an alert on, or you could potentially use for analysis. So certain people are okay with eviction events. They are, if a bunch of pods get evicted from a given node, they they may have planned for this, or they're used to the node automatically like kind of scaling up to meet the new demand. But for us, it usually means things are going wrong. So it's something we're going to want to look into. After that is storage specific events. So this is related to like anyone who's setting up some type of volume on their like pod, or maybe you're setting up some type of like persistent volume storage. And the two key ones to look out for here are failed mount and failed attach volume. These will happen when maybe you create a new pod, it'll try to attach your volume to it, it won't work, it'll fire this event. There's a lot of like config maps that are passed in through volume, so it could mean that your pod doesn't have the necessary config variables, and you're going to see kind of like these cascading failures from here. So definitely something worth looking into if you kind of consistently see it. Sometimes Kubernetes will auto recover from these events, I've seen at least, but it's something that you should at least be kind of aware of. Next is scheduling events. So this is kind of more related, similar to like your lifecycle events. So you can catch basically failed scheduling through the scheduling events. So example is like you might want to set a event alert on failed schedule. And this means that Kubernetes, you have a pod and you want to deploy this workload, and Kubernetes went to schedule it and it can't. You can't put it on any node. The workload's not running, not great. It could be that there's no nodes available, there's not enough resources available, or maybe you have some taints or toleration set up that are preventing the scheduling. So definitely, most cases, something that you're going to want to look into. Scaling events, kind of like wrapping it up here, are anything that fires like either through the horizontal pod autoscaler or the cluster autoscaler that are going to let you know, kind of related to load, like if you're adding or removing pods. So this is mainly used for analysis. I often look into this to see like when are we scaling, what times of day is the autoscaler running. Can kind of line it up with like performance. But yeah, more for like looking at like analysis in the cluster. Yeah, and that's kind of like the quick overview of like the different types of Kubernetes events, which ones you should be looking out for. And from here, I was gonna, just bring up my terminal, kind of show you guys some like example use cases. There's a bunch of different tools you can kind of use to drill into these events. One of them being like ours, but there's, you can use like the terminal. You can use something like setting up like the Prometheus event exporter. I think there's like tools out there to do that. And you can kind of like ship them to whatever system you want. So yeah, I'm just gonna pull up my terminal here. Hoping everyone can see this. Cool. So yeah, the kind of the two events or the two commands I described earlier were K8s events and K describe the object and then the resource. So an example of K8s events is you're going to see, all of the recent events in your cluster, the message saying what's happening, of reason, which is kind of just like a short description, the object it came from, and the type. So like this is a great example because like failed get resource metric. It's not something I might not have even known about, but what's happening. The pod autoscaler can't get CPU utilization. So what does that most likely mean is that the pod autoscaler isn't going to work correctly. And so this is something that like could have affected, us scaling up in the future. It's something that I wouldn't have even known about if I hadn't have like looked into these events or if I wasn't, exporting them somewhere to look into. The downside of just doing everything from the terminal is, show you another example. So let's take this evicted pod right here. And K is just an alias for kubectl. It's essentially what I'm doing here. I'm going to describe this pod. And so I'm describing a pod that was evicted, right? So I know that there should be some evicted related events, but there's none. And so why is that? It's because by default, Kubernetes doesn't store these events for a long time. And so if you're not exporting them to some external system, you're just gonna like lose some of the data. So kind of the key thing I'm harping on is, whether it's Prometheus or some other observability tool, I think it's, the first step is just sending them somewhere so you know what type of events are even firing inside of your cluster. Because or else you're going to lose them. And that's why if you saw that, like when I ran the get events, there's only 4 of them, and they've all fired pretty recently. It's because all of the older events are gone at this point. So yeah, just a lot of the cool data you're going to lose if you're not if you're not pushing everything somewhere else. Yeah, then I guess like the last thing I was going to walk everyone through here is kind of some analysis you can do. I'll give an example through ContainIQ, but there's a lot of different tools you can use for this. And so, yeah, one of the things we do here at ContainIQ is help people, monitor observe, and alert on Kubernetes events. And so, like I said, to get the most value, you're going to want to export them somewhere. And it's kind of actually where we started, was a better way to store and alert and visualize all of this like cool event related data. So yeah, at a high level, like, okay, now you've got all this event data. What are some things you can do with it? So I think something that we do that's interesting, or something that I'll do, is I'll look at the scaling replica set event, and I'll see, over the past week, how often is our replica set scaling up? What times of day is it happening? And I'll segment it by like hour or minute or whatever, to get an insight into, how often is this occurring? Maybe I find out that we're constantly scaling up, and I need to, maybe tweak the thresholds where the scaling's happening a little bit, or maybe the scaling's leading to other issues. You can kind of just get like a deeper insight by graphing these different events over time. Another super common use case is just like looking at your warning events to know, like, you might not even realize what you should be looking out for, because the warning event's fired and now they're gone, and so you don't even know. And so yeah, I'll just like open up the warning events, I'll drill into like maybe a given time period, and then I'll kind of paginate through them to just get an idea of like, okay, what happened over the past 24 hours in relation to warning events. So you can see there's some related to like pulling an image, some like failing to attach a volume, which is something I mentioned earlier. So this, I would want to like investigate why this is happening. Yeah, it basically just gives you a way to kind of see like what exactly is going on in the cluster. The final thing is you can also just search any Kubernetes resource. So similar to when I ran that kubectl describe pod, you can essentially search any pod or resource name in a tool like ours, and it'll show you, all of those events for that pod. And again, like you don't have to worry about them being discarded. We also automatically associate logs, which is kind of a nice addition, because maybe your pod went into a crash loop. You want to know why that is. We'll automatically pull in the logs at the time that the crash loop occurred, so you can see, maybe your container was logging an exception, just causing the pod to be restarted, and then it restarted enough, it went into a crash loop, and now your application's not running at all. Basically just giving you a better way to debug why things are going wrong, which we kind of talked about at the beginning, is super important. Once you have the alert, now it's time to figure out, how do I resolve this as quickly as possible, and so it affects the least amount of users. Yeah, I guess like the final kind of thing is you can also set event alerts. So I will often set alerts on a lot of the things in the slides I showed earlier, but we enable basically default alerts for people, where we will set up alerts for things like failed scheduled events, pod evictions, node CPU and memory limit reached, really any precursor to outages inside of your cluster. And yeah, with that, I will kind of open it up to questions from anybody. If anybody has any questions or thoughts, happy to answer them here.
There was a question that came in from Harsha earlier, which I'll post to you, which is what tools are you using for observability, aside, I guess, from ContaiNIQ?
Yeah, that's a great question, because there is a ton of tools out there, and I think what you should use depends on a lot of your situation, and maybe your familiarity and experience with those tools, as well as like your budget. So internally, we heavily dog food all of our own tools. The reason for this being kind of like we have some like kind of native insights that you won't necessarily get out of the box with other tools, and they're super important to our specific kind of use cases. And so like we essentially need to use our own tool for those. But for like, I guess like more general purpose, I think it's pretty common to see people using something like Prometheus to gather metrics. It's essentially like a time series database. The graphing capabilities they're good, but they're not super user friendly. So typically you're going to want to export those metrics somewhere else, maybe something like a Datadog or Grafana or a New Relic. You're going to want to like send that data there for kind of like the visualization and alerting. For us, it's really, we're using like Prometheus to grab the metrics, we pipe them into our own system, and we use like our own tool internally for like monitoring and alerting. Yeah, there's a lot of tools out there. I think in Kubernetes, the most common use case is probably Prometheus, Grafana. That being said, I've heard a lot of people say that if you don't have a team dedicated to it, you should look for a more managed solution, because it can be monitoring can be scary, and you can definitely run into some issues and bugs. So depending on your experience, I think that determines, and the size of your DevOps team, I think that determines, whether you're looking to self-host or use a managed solution.
I've actually got a couple more questions that I'm going to pass your way, if that's all right. One came from Pasan Don. Does ContainIQ integrate with Prometheus or Kibana, or are they does it exist outside that sphere?
So the way ContainIQ works is essentially we collect all of that data for you, so you don't have to run those tools yourself. You can still like push Prometheus data, but the goal of ContainIQ is really to reduce the workload of you having to run those tools yourself. So like we'll automatically collect and aggregate your logs for you and correlate them with events. We'll automatically collect metrics and all of that stuff for you, so that you don't even have to worry about Prometheus. We will like integrate with some of those tools, but our goal is that you don't even have to worry about them.
That's cool. Kind of related. There's a question in the chat from Amruta Bandhu, and these events that you've been describing, they're sort of correlated and dependent on each other. So I'm guessing what ContainerIQ kind of does, like you said, you're collating all of it to kind of get an insight into sort of the kind of how the sort of relation of various events happens, and sort of to provide a kind of insight and actionable sort of thing that you can go from there. I butchered that question. I'm sorry.
No, I got the general direction. Yeah, I mean, the correlations, the most common correlation we see is actually not even necessarily with other events, but it's with logs. Like you're going to want to see maybe the logs that in the pod that were firing at the time the event occurred, or if it's more of like a system level event, maybe an event in Kubelet, you might want to see the Kubelet logs right as that event was firing. So I think the most common correlation is not necessarily between the different events, but it's between events and other things. So logs, metrics, information like that. And you can always roll it up like through the aggregations to like, graphing how often a given event occurs over time by like segmenting by like hour or day or whatever.
Yeah, I really like that example that you gave where it was like these scaling events kind of happen, like do they happen every 6 hours or whatever, and then you can kind of relate that to other things that about based on your other monitoring. Is like, okay, this happened because we see this morning spike when everybody comes in and does whatever, right?
Yeah, it's kind of like the DevOps nerd in me loves saying that. It's like, okay, when's our load coming in? You know, when are we scaling? It's definitely a lot of fun to kind of graph those different things over time.
Yeah. I think Amrita's just followed up. It's like, any tool you know for this correlation. I guess a lot of it is just, I mean, it's not so much a tool, it's a process, isn't it? Correlating that stuff, like knowing what you're putting together, right?
Yeah, I think I mean, we're obviously like a tool that offers like a lot of the log event metrics correlations, but it's really anywhere you pipe the data that gives you the ability to kind of like graph multiple things over time. That's kind of the core of what you're going to need for the correlations. So just a system that accepts a bunch of different ingest and will let you correlate across like those kind of different ingest feeds.
Yeah. Cool. Well, I've just seen a YouTube question as well. Is there's a ton of tools out there, but what are beginner-friendly tools for monitoring and observability? And I'm guessing, I mean, ContaiNIQ is, you know, considering that this is all fairly complex stuff anyway, and Prometheus is difficult. You know, ContaiNIQ kind of looks like it's a friendlier way, but you also did mention, like, you know, various other subscription type tools. But maybe have you got any ideas about like what are beginner friendly sort of monitoring tools?
Yeah, so yeah, and obviously I mean that's kind of the inspiration for why we built this, is because I was super unhappy with a lot of the other tools, and I thought we could really simplify some of the data and correlations, the common use cases that people needed. I think generally, this is kind of just my opinion, the paid solutions are generally more user-friendly. The open source tooling is generally a bit more work. Just from talking to people in the industry, if you're using like a setup like Prometheus and Grafana, you're usually going to need a team to stay on top of that. We've seen a lot of cases where people set it up and either things went wrong or they're like, this is just more headache than I originally imagined, and then they migrate to more of like the paid tools. So yeah, I think generally that's where you're going to see the more ease of use focus. But if you want to get your hands dirty with like some more complex stuff, that's, you know, free and open source, Prometheus, Grafana, you know, Thanos, Loki, Jaeger. That's kind of like the stack you're going to need to get the full insights. Again, it's going to be much more kind of uncomplicated to set all that stuff up though.
Yeah, and yeah, you can set it up exactly the way that you want it to, but you're dedicating your own time and resources to doing that. As much as really good dashboards, you know, for Grafana already exist out there, like you'll still have to probably fine tune it for your specific use case.
Yeah, I think it's entirely dependent on, you know, what type of data you're. If it's just, you know, simple metric level data, then might not be that worth to set all that up. But if you're looking for like trace to log correlations, and like automating a lot of that stuff, it becomes a lot more involved. So again, you know, your mileage may vary, and it really depends on the use case. It's hard to give a concrete answer.
Yeah, no, fair enough. I mean, it as with everything, it depends, right?
Exactly, which I'm sure people hate to hear.
No doubt.
But it's kind of the truth in this case.
Yeah, because if there was only one defined way of doing things, then we'd all be doing that, and there would be no innovation or whatever, you know. And there is tons of innovation in the space, so it proves that there are good new ways of doing stuff.
Everyone's trying to do things just a little bit better than, you know, the previous generations of tooling. So it's the landscape's constantly changing, and, you know, with things like eBPF, which is a pretty cool new technology I recommend people check out. which allows you to like hook into the kernel directly. I think like the possibilities of what you can monitor and what you can get out of the box are really changing, and you're going to see a shakeup in the landscape over the next few years.
Well, I think that's a really good note to end on, because it's sort of looking ahead into the future, and I think we are all done with questions. So Matt, thank you so much for taking the time. Thanks for your presentation. Yeah, if there are any questions that pop up later on, definitely join us in the Civo community Slack. So as soon as you have a Civo account, you get an invitation to join the Slack. And any questions that pop into your head, feel free to ask, and somebody from the team or the rest of the community, there's thousands of us there, will be able to advise. Cool. Well, thank you very much, and see you again in a couple of weeks for another one of these, I think. All right.